Cosmic intruder. Alert, the enigma of 3I/Atlas unveiled. Picture this. A rogue wanderer from the depths of interstellar space hurtles toward our sun at breakneck speeds, defying expectations with bursts of activity that hint at secrets billions of years old. Meet 3I/Atlas, the third confirmed interstellar visitor to grace our solar system, discovered just months ago and already rewriting the rules of cosmic nomads. Unlike its predecessors Oumuamua and ATLAS, this carbon dioxide-rich comet is sparking wild speculation, from ancient origins predating our sun to whispers of alien technology, while telescopes worldwide capture its evolving tale and mysterious emissions. In this video, we'll unpack the massive updates on its strange new behaviors, from early outgassing to unusual dust patterns, proving why 3I/Atlas is the hottest topic in astronomy right now. Buckle up as we dive into the details that could unlock the mysteries of other star systems. The discovery of 3I/Atlas marks a pivotal moment in interstellar astronomy, as it was first detected on July 1, 2025, by the Asteroid Terrestrial Impact Last Alert System, ATLAS, at its station in Rio Hurtado, Chile, initially designated as A11PL3Z before being confirmed as an interstellar comet, and renamed C2025N1, ATLAS. This makes it only the third known object from beyond our solar system to pass through, following the cigar-shaped 1I/Oumuamua in 2017, and the comet-like 2I/Borisov in 2019, highlighting the rarity of such events, and the improving capabilities of sky surveys to spot them. Pre-discovery images from NASA's Transiting Exoplanet Survey satellite, TESS, later revealed that the comet was already active as early as May 7, 2025, when it was about 6.4 AU from the Sun, far beyond Jupiter's orbit, suggesting an unusually volatile composition that activates under minimal solar heat. The object's interstellar origin was confirmed through its hyperbolic trajectory, with an eccentricity of 6.1396, the highest recorded for such visitors, indicating it's unbound by the Sun's gravity and speeding through at a hyperbolic excess velocity of 58 km/s. This discovery not only expands our catalog of extrasolar bodies, but also provides a fresh opportunity to study material from distant star systems, potentially offering clues about planetary formation processes that differ from our own solar nebula. Orbitally, 3I/Atlas follows a highly eccentric retrograde path with an inclination of 175.11 degrees, meaning it approaches the solar system from the southern celestial hemisphere, opposite to the direction of the Sun's motion through the galaxy, which is unusual for interstellar objects. Its perihelion, or closest approach to the Sun, is set for October 29, 2025, at 1.3564 AU, positioning it between the orbits of Earth and Mars, where it will reach a blistering maximum speed of 68.3 km/s under intense solar radiation. Before that, it will make a close pass by Mars on October 3, 2025, at just 0.1937 AU, about 18 million miles, offering a prime viewing window for Mars-orbiting spacecraft like NASA's Mars Reconnaissance Orbiter, MRO, which plans to capture high-resolution images with its HiRISE camera. Post-perihelion, the comet will swing by Venus on November 3, 2025, at 0.6494 AU, and then Jupiter on March 16, 2026, at 0.359 AU, potentially perturbing its path slightly due to the gas giant's gravity. This trajectory ensures it poses no collision risk to Earth with its closest approach at 1.8 AU, but its retrograde motion and high speed make it a challenging target for detailed study, emphasizing the need for coordinated global observations to track its evolution. Physically, 3I/Atlas consists of a solid icy nucleus estimated to be between 0.32 and 5.6 kilometers in diameter, with Hubble Space Telescope observations from July 2025 suggesting it's likely less than 1 kilometer across, making it smaller than many solar system comets, but still capable of significant activity. Surrounding the nucleus is a coma, a fuzzy envelope of gas and dust, measuring up to 26,400 by 24,700 kilometers, with a larger carbon dioxide gas coma extending at least 348,000 kilometers, as captured by the SphereX telescope at distances of 3.3 to 3.1 AU from the Sun. Recent images from the Gemini South Telescope on August 27, 2025, show the comet developing a signature tail of ice and dust, growing as solar winds strip particles from its surface. with the coma swelling to reflect more sunlight and enhance visibility. The comet exhibits a sun-facing dust plume and a faint anti-solar tail, expected to elongate dramatically as it nears perihelion, potentially becoming several times wider than the nucleus itself. Its rotation period, measured at 16.16 hours, causes brightness variations that have decreased as outgassing intensifies, indicating a dynamic surface responding to solar heating in ways that reveal its structural integrity. Compositionally, 3I/ATLAS stands out for its unusually high carbon dioxide content, with James Webb Space Telescope (JWST) observations on August 6, 2025, revealing a CO2 to water mixing ratio of 8:1, one of the highest ever recorded in comets, and suggesting formation far from its parent star beyond the CO2 frost line. It also contains water ice, water vapor, carbon monoxide, and carbonyl sulfide, but is notably depleted in carbon chain compounds like dicarbon and tricarbon, pointing to a chemically primitive makeup. The Very Large Telescope, VLT, detected cyanide gas and atomic nickel vapor in its atmosphere, with emissions ramping up as it approaches the Sun, yet intriguingly, no iron vapor was found despite the presence of nickel, which deviates from typical cometary spectra. This composition implies exposure to high radiation levels in interstellar space, or unique conditions in its origin system, making it a valuable sample for understanding how volatiles survive long cosmic journeys. The reddish hue of its coma, indicative of large dust grains, further supports a mix of icy and dark refractory materials similar to distant trans-Neptunian objects. The observed behaviors of 3I/ATLAS include early and sustained outgassing, starting at 6 AU from the Sun, farther than most comets activate, driven by the sublimation of carbon dioxide ices that require less heat than water. As it zooms inward at over 130,000 miles per hour, its coma shows high negative polarization, suggesting a heterogeneous surface with both fresh ices and ancient radiation-processed material. No major outbursts have been detected as of late August 2025, but its brightness has steadily increased, reaching potential binocular visibility by late September at magnitude 14.4. Recent time-lapse and multiband imaging reveal unusual dust patterns, with particles ejected sunward at tens of meters per second and spreading slowly perpendicular to its orbit, differing from solar system comets and hinting at distinct ejection mechanisms. This activity, combined with its retrograde orbit and lack of a pronounced tail until recently, underscores its adaptation to solar influence, providing real-time data on how interstellar bodies interact with a new star's environment. Among its strange aspects, 3I/ATLAS's estimated age of 7.6 to 14 billion years, potentially older than the solar system, raises questions about its survival through galactic travels, possibly as a relic from the Milky Way's thick disk population. The absence of iron vapor alongside nickel emissions puzzles scientists, as does its origin from the galactic south, counter to expected interstellar flow directions. Harvard astronomer Avi Loeb has speculated it could be alien technology due to its odd light emissions and lack of a traditional tail initially, but mainstream observations confirm natural cometary traits, with no technosignatures detected in searches for artificial signals. Its high CO2 abundance and depleted carbon chains suggest formation in a cold, distant region of an alien protoplanetary disk, while its erratic, unpredictable path adds to the enigma, defying simple models of interstellar ejection. These anomalies make it weirder with each observation, challenging assumptions about cometary evolution and sparking debates on whether it represents a new class of interstellar objects. Telescope observations have been crucial in unraveling 3I/ATLAS's secrets, with Hubble providing detailed images of its nucleus and coma in July 2025 and planning ultraviolet spectroscopy in November to analyze gas emissions and sulfur-to-oxygen ratios. JWST's mid-infrared data from August revealed its gaseous composition, with further sessions scheduled for December post-perihelion to track changes in activity. 4 major telescopes, Hubble, SPHEREX, JWST and TESS, collectively confirmed its bizarre early outgassing and CO2-rich atmosphere, with SPHEREX mapping the extended coma and TESS uncovering pre-discovery activity. Ground-based facilities like VLT and Gemini South have captured spectral lines and tail growth respectively, while ESA's tracking emphasizes its cometary nature. These multi-wavelength efforts, including planned observations from Mars orbiters, ensure comprehensive data collection, turning fleeting visits into lasting scientific legacies. Scientifically, 3I/ATLAS holds immense significance as a window into extrasolar chemistry and early universe conditions, its high CO2 suggesting formation in environments unlike our Oort cloud, potentially during cosmic noon when star formation peaked. By studying its dust and gas, astronomers gain insights into galactic dynamics, the longevity of icy bodies in interstellar space, and how such objects might seed planets with volatiles, possibly influencing Earth's water origins if similar ones were captured early on. Its age and composition challenge models of planet formation, while its behavior tests theories of cometary activation under varying stellar influences. As the first interstellar comet with such detailed scrutiny, it bridges gaps between solar system and extrasolar studies, fostering international collaboration and inspiring public fascination with cosmic visitors. Proposals for missions to 3I/ATLAS highlight its once-in-a-lifetime potential, with studies exploring intercepts by existing spacecraft like NASA's Juno during its Jupiter close approach in March 2026, or new launches from Earth or Mars for flybys. The Mars Pass on October 3rd offers a unique chance for on-location views, with MRO's HiRISE potentially resolving the nucleus from the dust cloud, providing data unattainable from Earth. Feasibility analyses suggest spacecraft could rendezvous to sample its coma or tail, analyzing pristine interstellar material directly, which would revolutionize our understanding of alien worlds. While challenges like high speed and short notice persist, these ideas underscore the urgency of capitalizing on rare interstellar encounters. Recent massive updates on 3I/ATLAS reveal escalating strange behaviors, with its tail visibly elongating in Gemini South images and JWST detecting odd light patterns that intrigue astronomers. As it heads toward Mars, the mystery deepens with unusual dust spreads and nickel signatures sans iron, fueling speculation while searches confirm no alien probes. With perihelion looming, expect more revelations as solar heat bakes off layers, potentially unveiling hidden secrets of this ancient traveler. If this cosmic thriller has you starstruck, smash that like button, subscribe for more space updates, and drop in the comments. Do you think 3I/ATLAS hides alien tech, or just interstellar quirks? Stay tuned for perihelion drama, space is full of surprises.